So I'm Kasun. I'm the CTO at Surge Global, and currently, basically, I was at Surge for about a couple years now, and from the inception of its engineering bandwidth, engineering, um, uh, it's from the point where we started going big on the engineering aspects, and before that, I have about 12 years of career exposure with various companies like WSO2 and few Australian startups, as well as my few of my own startups as well. So majority of my career has been hands-on development, and then a few years I have been working as an architect, and then I joined Paladin, which was basically acquired later by Surge. And from that point onwards, we actually built a great great workplace and great engineering culture for Surge. And so like today, we are basically passing 120 plus engineering, just pure engineering, and overall Surge, we have about more than 400 people now. So that's basically a brief history to my background. And this specific session, basically, like Technoid is also an initiation. Am I, Chandur, am I like, was I mute?
No, you can continue.
Okay, did you hear me till now?
Yeah.
Okay. Sorry about that. So anyway, sorry about that, guys. Now, so Technoid as a community, like we just want to build a community within Sri Lanka first, and then when we are in a special like position where we need to be in the local context, we will also look at going out of country as well, like to international crowd, basically making this a knowledge sharing place so that everyone can collaborate and build a better engineering culture. So like with Technoid, we have started a various bunch of talks, and this is going to be another special like handmade special series of sessions completely made targeting architects and senior engineers. So this will basically like have about, I think more than 10 episodes, because we have so much to talk about. So mainly I'll just show you a rough lineup for now. So we will basically talk about enterprise architecture. And so we actually start at software architecture. So there's a big difference between enterprise architecture and the usual software architecture. So we will start at just giving a small definition to enterprise architecture, and then we will move towards, because majority of the audience which is joined, and as well as which will be joining in, they will mostly be in the like software engineers or tech leads, or let's say architects. That space is the majority of the audience. Because of that, we thought we should line this up in a way that we can groom an architect or groom an engineer or a tech lead to the next level, and give them the thinking pattern which an architect should have, and then give them the technical understanding and the depth that an architect should get, and then convert them towards enterprise architecture, which I will tell you in a while. So enterprise architecture has a very wider scope compared to architects. So we will discuss all that. So basically within this like series, we will be talking about software architecture, and basically the role of role of an architect. And from that point onwards, we will be going through the major like consideration when it comes to software architecture, which is performance, security, reliability, scalability, and then we'll move towards clean architecture, and then we'll be moving towards the fundamentals of enterprise architecture, and few diagramming techniques that you need to follow, and then we go to a little infrastructure level stuff that you should know, and then we'll go towards the closure. But there will be a lot more additions to this, especially during the last few topics, because there are few areas that and like if we take the certification that enterprise architects should follow, TOGAF, TOGAF is one of the prominent certifications. So we will try to cover at least what is covered in TOGAF's fundamental few certifications, so that like this series will give you guys a comprehensive coverage. So let's basically start today's bits. Today won't be a like pretty shorter session with which gives you like the start, and then we will probably have the next sessions, like which is the episode 2 in about another 3 weeks time. So fine, today we are basically going to understand what is enterprise architecture and its goals, and then software architecture, and basically try to understand the differences between the two. And then we are going to start like this jump into the performance aspect, which is one of the concerns that software architects should definitely, like one of the main concerns, right? And we start with performance, and then if the time permits, we will also go towards discussing about latency as well. So let's move forward. Right. So now, give me a second. I'm just, this window is troubling me. Okay, fine. Okay. Now, if we try to define what is an enterprise, basically an enterprise is a group of people and resources devoted to achieving a mission. So here, if we think about mission, it's a broad term. It differs from an organization to organization, right? But basically, it's a group of people and resources devoted to achieving mission. So it can be basically 2 or more people. It could as small as that as well. But when it comes to enterprise architect's role, even the smaller organizations should have an enterprise architect. Even it's 2 people, there should be someone who should really fill that role. But in our scope, we are trying to get to like the level of where thousands of people and organizations with thousands of people, and there will be obvious challenges, so that his role will be definitely tough. So if we think about larger organizations, they actually become large mostly by acquisitions. So acquisitions means like, as an example, if you think about Surge acquired few companies over the last 1.5 years. So as an example, we acquired a company called Paladin, and which gave us the initial engineering capabilities. And then Surge acquired a company called Trebea, which gave us the data science related expertise with about 40-50 engineers. So likewise, organizations will become large by acquisition, as well as when, like if we think about a company, a multinational, sorry, not a multinational, So like nationwide, a massive company like telecom, they also have various complexities. They have subsidiaries, they have partners, they have various vendors which provide stuff to them. So structures are getting complex with growth. So sorry, okay. And if we think about the role of an enterprise architect, enterprise architect is basically the person who models the enterprise. It isn't necessarily, it's not necessarily actually, it isn't a software architect. So software architecture is a small but an important component of enterprise architecture. So if you are an enterprise architecture architect, there could be a bunch of, in an organization where there are thousands of employees, there could be few architects working under you. So in a technical company, in an pure engineering company, enterprise architect would mainly run the technology perspective and enterprise architecture's technology perspective, as well as the entire governance model. So that's basically what the role is. Basically, he will roll out a plan, and software architects are there to really execute this whole enterprise architect's plan. Now, if we move a little further, now, if you think about the main goals that an enterprise architecture should handle, it will mainly be like, Chandur, are you talking about?
No, Kasun, you can continue.
Okay, fine. I just heard something aside. Anyway, so if we think about an enterprise architect's goals, they are mainly, if we think about an organization as a whole, his goals would be to improve effectiveness, efficiency, agility, and continuity. So if we be specific to effectiveness, so we can say that an organization effective if these kind of like pointers, like as an example, if the business stakeholders are clear about the technology roadmap and the whole business processes, and then if the strategy executives are clear about the business architecture and capability models, if the product managers have clear guidance on technology to reduce project risk and cost, and if IT leadership has strategic guidance. So if all sort of points like this, if all those things are met, then we can say we have effectiveness. Similarly, when it comes to efficiency, now an enterprise architect should also guide sales as to why customer he should know, so why customer acquisition, if the acquisition cost is higher, he should know it's basically, it can be lower, and he should identify the procedures to lower it. And so as an example, he should identify overheads and have plans to eliminate overheads. And if we move a little further, now agility is the other concern, which is now let's say business analysis, documentation, and modeling sounds like it sounds like an overhead to engineers, right? They never document. But ideally, if we scale up an enterprise to thousands, or like if a project team has about 10-20 people, it could change at any given time, right? So because when the organization gets larger, the challenge in like plugging in new people or pull out new people, because let's say as an example, a bigger, like if we think about a company like, let's say Virtusa, or like massive organizations which have like thousands of larger projects, so there are certain like vendors working with them. So let's say a project is going on And at one point, there is a problem. Let's say there's an integrity problem with a specific vendor who's like working in the project. Like, let's say vendor has put about 10 engineers to the project. So management decides to pull the whole, like plug the whole vendor out of the project. So the project is going to lose about 10 engineers, probably with an architect and a tech lead as well. So in that case, if the documentation and if the proper like processes, and if the deployment is properly documented, and if those things are not properly there, so that particular situation should be a disaster. So they definitely have processes to cover those things up. So like that, enterprise architects should ensure the confidence as well to the management, as because they should ensure that the knowledge is centralized and it's properly documented in a way that those kind of situations are properly handled, right? And then the next point is basically the continuity. Like, it's the same thing where we should preserve that knowledge with the change. So, like, as an example, if there are certain, like, let's say the product has released about couple releases, and in that case there are significant amount of changes to definitely the architecture as well as the deployment, if it is be specific to a software product. In that case, if we don't properly manage versioning, and if we don't properly document every single version, then again we run into the same rabbit hole. So we should ensure that enterprise architects should ensure that that's all covered as well. So now, like, thus far we've actually spoke about the role of an enterprise architect to be very specifically, right? But the audience here should have some sort of a confusion, because as to, okay, we are technical, we work on like technical projects, and our main focus is to learn technicalities. Yes, that's true, but like, through this whole series of discussions, or series of webinars, our target is to basically give you the knowledge, or at least the pointers for you to think and start studying to get to the end goal, where, okay, from the developer, you should get to, like, I don't like to even to use the word developer as well, because I like to call you guys an engineer. So from an engineer to senior to a technical lead to then architect, and then to enterprise architect. So that whole pathway, we will actually start this session series with the point of a software architect, and we will like talk about architects, basically the major knowledge points that architects should have, and then move towards the enterprise. So this will be a guidance for architects to become enterprise architects. But we will first consider the knowledge base that an software architect should have. So now, from this point, the session will completely deviate from the enterprise architect pathway to the architect's pathway. So now, if we think about a software architect, purely, just forget about the enterprise architect role now. This is just the introduction, and that is the end goal of this whole. Let's say this will have more than 10 episodes, as I said, but that's the end goal. But now we shift to the software architect completely. Now, performance, like when it comes to a specific software like solution or a platform or a framework, software architect's concern, the major consideration should be like performance, security, reliability, and scalability. So these, we call them non-functional requirement in a project. So if you prepare an architecture documentation for a large-scale project, we call it like we have a section called non-functional requirements, right? So that's one of the major concerns for an architect. So non-functional requirements, cross-cutting concerns are like the major, because those are the things that they like architects should really focus on. While because for other stuff, the application level stuff, we always have tech leads to senior engineers who are really capable enough to really look at like development or the engineering specific items. But as an architect, you should really oversee, and you should really like foresee items that might affect the system's performance, reliability, scalability, and security, as well as he should really take the lead on technology selection as well, because that also should be a decision you should take considering the non-functional requirements, to be exact. Now, if we be specific to performance, performance is purely about minimizing latency and increasing the throughput, right? So I will tell you what the throughput is and what the latency is in the next slides to come. And then the next thing is basically scalability. Scalability refers to mean that there could be a non-functional requirement saying, okay, this system should support 1 million users at any given time. So if that's the case, can the system scale to work with 1 million parallel users? So that's basically the scalability requirement. So then if we think about reliability, you should think about resilience to failures and availability. While let's say one component fails, then how do you handle the availability? Or what is your failover mechanism and things like that? So if you come to security, security is definitely like the security of data at rest and data at transit, basically securely transferring or storing data, and handling how do you handle the authentication, how do you handle authorization. If your platform is an let's say white labeled or a software as a service, how do you connect to the connecting enterprises user base? Or would it be through something like Active Directory? Would it be through LDAP? Then if you fetch data from it, how do you secure them? And how do you comply if it's Europe? How do you comply GDPR? So things like that, everything comes under this specific portion. So then deployment, like you all know, like high scale systems are not easy to deploy. They require a lot of coordination and automation as the system's complexity grows. So because of that, that also has a massive importance, especially with the sophisticated like elements now we now have with cloud. People tend to use a lot of cloud native services as well. So because of that, we always need to like strengthen the deployments, automation, and the especially the documentation side of things as well. And then last comes the technology stacks. So like we have like various caches, queues, databases at the moment, like in the current world. So pick which one to use depending on the system's requirement, like whether we need a cache, where do we need a cache, like what kind of operations we run, and depending on that, do we need a cache to that point, like things like that. Do we need a queue? Do we need to convert this to an event-driven model? So things like that would all be decisions which should come from an architect. Like more than 90% of those decisions will really come from non-functional requirements you capture in the initial requirement gathering. So if we move a little further, at Surge, we actually we are in the process of building our own solution architecture framework, and basically technology adoption framework, like which will really give the architects and tech leads as well as the senior engineers the guidance to really look at a solution in different angles. So basically it pushes them to look at a broader perspective, like as an example, business, process, stakeholder, market, architecture, production, as well as technology stack. So we have 3 stages where discovery, definitions, and then finally the delivery point. So we have identified a few steps in that particular like 3 main stages. So mainly even the senior developers or tech leads should really follow that, because when they have the whole coverage between all these stages, then only we can really take better technical or else architectural or else design, or else even if when we build the logical layer, this will actually help us make better decisions. So and also, since like we maintain a bottom-up approach on the solutioning aspect as Surge, this will also ensure upskilling our leads and engineers in a way that they think about these aspects. Because if you think about normal like legacy organization, you can see like the solution comes from top. That's always the case. So there will be an initial business analyst working with the architect in the usual case. So architect comes up with the design and architecture documentation. Then architecture documentation has all the solution decisions and everything. Then it's passed to the tech lead, and tech lead takes certain decisions, and then it passes to the end engineering team, which is the current way that is being handled, but in the majority of the companies. But at Surge, we follow a bottom-up approach where the solutioning, like the requirement gathering phase itself, we will really incorporate developers, quality assurance engineers, business analysts, product managers, as well as architects together to identify the requirements, identify the non-functionals, and then work on the design, come up with modeling. Like we usually use C4 modeling. So come up with that, and then they take that to the architect for the review. And then we with the panel review, we take the final decisions and get to the actual development stage. So it's a bottom-up approach. It will give a 360-degree visibility as well as exposure to the senior engineers or engineers as well as the tech leads, so that it's basically mainly done by them and then reviewed by the senior peers. So in that case, it'll actually strengthen that tier. So that is actually, it's not just us. If it's the same strategy which is followed even at the companies like Google, Facebook, so you can find out that's the same thing they do as well. So this will also help improving customer, because we always interface our engineers or our leads with the clients. So this will definitely improve customer relationships as well, and definitely the team bonding, of course. Moving forward, so just to talk a little more about the enterprise, slightly more about the enterprise architect survey, like the things we discussed about the documentation and all that process. So at Surge, we follow like we have a bunch of like we have made the Confluence documentation, like for the architecture point of view to the end deployment. We have made the Confluence documentation mandatory, and that covers setting up, and that covers like setting up the project, as well as from setting up from the architectural decisions, from meeting minutes to everything needs to be documented every version needs to be documented. That's a mandatory thing. And from when it comes to deployment, the Terraform, like doing the Terraform script and deploy through Terraform and make deployment versions on the Terraform is mandatory. So we have certain, like we are trying to adapt some governance mechanism where we have come up with our own boilerplates to, as an example, we have a MERN boilerplate, we have a Go boilerplate, we have a Terraform boilerplate, so that teams can use it. Like that already has, those boilerplates already got the initial fundamental like standards, coding patterns, standards, like the basic structure we follow. So that will be consistent throughout the project. So that's the idea. So likewise, we have very strong product management process as well. So with all that, we ensure that the factors, efficiency and everything, the factors we've spoken about under enterprise architect is covered properly. Now, that's just an example, and we can do many things like that to ensure the agility as well as all the factors we've spoken about. So now we are getting into one end object, which is like now if we think about software architects, like few major concerns, like we have latency, concurrency, caching, performance basically is one of the major concerns. So under performance, we talk about latency, concurrency, and caching. Those are the three main pillars we should talk about when it comes to performance. Now, under this topic, we will basically talk about what is performance and how do we measure performance and how do we improve performance and how we can minimize latency and what we can do, because latency, if we like be specific to latency, it can be pulled under 4 categories, which is CPU, memory, network, and disk latency. Then when it comes to concurrency, under concurrency, we discuss how do we improve concurrency. And like we also talk about concepts like locking and how to improve coherence in your code and things like that. And then we come to caching. So under caching could be static or dynamic data caching and how caching can help us improve performance. So under performance, we talk about those. So under the software architect's main key concerns, so performance is the first one. So like that, this is what I was going to say. I just yeah. So anyway, performance, reliability, security, scalability, and deployment as well as the technology selection would be his major concerns. So performance is the first one. Now, since we have a little more time, we'll start talking about performance. But before that, does anyone have, because I was blabbering all the time, so do you have any questions or any things that you want to know before we move forward? We'll take a minute probably, if anyone has questions. Okay, let's move forward. Right. So, like nowadays, if we think about the current like world with current engineering background, current world, we really don't think about like we don't think much about performance, as like we have like dinosaur like machines to work with, like because if you think about CPUs, like the resources that the computers these days have, like whatever, like how poor the code is, it will basically execute without an issue. But that will really come to a bad point if you really have to deal with a complex application, complex logic. So if you think about, if I ask you the question, like majority of the engineers or developers, they'll say, okay, if I ask this question, what properties are more important when it comes to an application or a framework, they'll say, okay, they'll give a bunch of answers like this: compatibility, functionality, maintainability, modularity. But if they are willing to sacrifice performance for these properties, why on earth you want to study performance? So so in one of the MIT computer science lectures, there was this line: performance is the currency of computing. So you can often buy needed properties with performance. So it basically tells us the importance of it. So you have to definitely, as if you are an architect, this is a mandatory aspect to learn, as I was telling previously as well. So as an example, I want to make it easier to program, or if I want to make it more secure, I'm willing to sacrifice some performance. If you keep doing this, now, like if you keep doing this, at one point, your system will really, if you want to compromise performance, it'll, at one point, with scale or with time, it will get unusable. So developers will not really care about this at all. But like, if you go to an end person, let's forget about software engineering or software as, it's just, if you go to a random person and ask, like random person who uses a computer, and ask, what you don't like about a computer, majority, like 80% of the time, they'll say, okay, this is slow. So why it's slow? That's because, like, the main thing is performance. There could be many tools and many things, many software elements which sorry about that. Wait, I think I'm getting a message. Yeah, I'll reply this message probably towards the end. So so because of that, we can say, like, performance is really important. Now, if we look at these computers, these are from, I think, 1964 to 1977, especially, like, look at the memory component. They're like, first one you see is it's a massive, you can see the computer is the one behind the typewriter and the table. So it had only like 524 kilobytes. So clock rate was 33 kilohertz. Now these days we talk about like gigahertz, right? So many like if you think about, because since the resources were very limited at that time, so performance engineering was extremely common at that time. So many programs, because many programs went straining the resources, and program had to be planned around the machine, and many programs wouldn't fit without intense performance engineering. Those were the early days. So then they went multicore, so introducing parallelism in the form of multicore processors to scale performance. They put many processing cores on the microprocessor chip. Nowadays, you can't just buy a single core, right? You just have to buy multi-cores by default. But anyway, now performance looks like massive multi-core processors with complex cache hierarchies, wide vector units, and GPUs, etc. Generally, software must be adapted to utilize this hardware efficiently. That's the ultimate factor that we need to keep in mind. We have hardware, but we need to utilize it properly. So if you want to have effective software, you must really worry about performance as a mandatory fact. Now, going a little further, now you can really like take this is also from a lecture, like from an MIT lecture. This slide deck has a link to it. You must watch that whole. It's a 1 hour lecture. You should really listen to the whole thing. Now, as this says, like they have done a research on the bugs in few or like popular open source projects to see like with the tag performance. So see like the growth from like, let's say growth after the 2004, you can see it has significantly improved, like not improved, it has significantly went up, right? So you can like clearly see after 2004-ish, people have started worrying more about performance. Like we know that the hardware and the complexity or the sophisticatedness went up, but with the time, people, especially the engineers, worry about the performance went down, hence performance issues went up. So this is basically the problem. This is why we need to really take this seriously. Now, if we also think about the career, like if you think about the careers or job interviews or new job offers or new job opportunities available in the market. So this is actually the sources from Monster, and where in software engineering, job adverts and interviews, mention of like performance drastically went up again, like knowledge on performance. So these jobs offers the selected people got are a few times higher than the people who are just like we say developers. As I said, I really have two perspectives as to developers and engineers. So developers, like I define them as like, okay, they don't really think about these important aspects when they code. They just need to get to the end goal, which is a working product. That's the only thing they consider about. But other than that, there are many things to think through, which is what the main focus of this whole series of lectures, which we are trying to cover and which we are trying to at least push you guys forward to think, right? Now, if we move a little further, now, mainly performance can be defined as the ability of a system to achieve its timing requirements. So using the available under the expected peak load. So in this definition, expected peak load could include high transaction volumes, a large number of users, or even additional transaction as a result of a software change. So performance and scalability are certainly related, but they are kind of distinct. So to illustrate this, consider the checkout process in an e-commerce site. Performance is where how quickly the system can process one customer's like purchases. Scalability is having multiple queues of customers and being able to add and remove checkout process as the number of customers changes. So most systems have performance concerns. Only systems with significantly variable workloads have scalability concerns. In addition, performance is concerned mainly with throughput and latency. Latency is like the response time. So although scalability deals with response time, it is also concerned with other aspects such as storage or other computational resource utilization. So performance degradation as the workload of a software system increases may be the first indicator that a system has scalability issues. Now, we need to keep above parameters fixed when we like measure performance. As an example, if we have large amount of data in the DB, it will affect the performance compared to less amount of data. So if the request volume is high, and also affect performance. So we need to keep these factors fixed when we measure the performance. We will definitely talk about these things in detail in the next sessions to come. Now, similarly, if we use state-of-the-art hardware or like increase the capacity, system is anyway perform better. So we keep these elements fixed and measure how fast we respond to a request from the browser, or how fast, if we do a batch process, if we try to test a batch process, how fast that gets completed. So with increased workload, our performance should remain stable. It shouldn't severely degrade. So if we improve hardware, it really perform better. So that's basically like a simple brief. So if we think about like performance, like if a performance issue occurs, we should really like start discovering as to how this has like occurred and why. So mostly it's a like result of like, if we think about how, it could mostly be a congestion at a network socket, or the DB is not able to handle request efficiently. Like if you think about the operating system, how we should see how much of CPU is available, how many threads that the system is able to run. Now, if we think about why, it could mostly be like, let's say if we have a like slow algorithm, it will slow down all the requests, and it will really queue the requests if in case there are like large number of parallel requests. So let's say we have ability to execute all requests in parallel, but it gets limited by the number of CPUs we have. So we have a ton of, as an example, the best example is like we have best example of the real life would be, we have a ton of like vehicles on the road, but the road has only 2 lanes per side. So more lanes will allow more vehicle to pass if you have more lanes. But if you don't have, like, the vehicle will get congested, right? So the same thing applies here. If you want to execute something on a like specific port, one after the other, let's say, or a serial in a serial manner, then as an example, if you're using a mobile banking app, a bank account should be locked, access only to a single thread at a time. So that's an example. So when you are architecting the system, you should identify where these queue buildups can happen. You should foresee them, and we should basically try to avoid them from happening. So then we have to actually like move to talk about the performance related principles, and we have to talk about how we can optimize, and where, like, what are the main trade-offs available, and how do we like we will actually try to go to the code level and explain you certain aspects. So I think since the time is very limited, we only have 5 minutes, so we will actually end this episode from this point. And we can like definitely talk more about it. We will definitely talk more on the next like session. Also, next session will also be completely on performance tuning and performance tuning. So we will actually end this from this point. So do you have any questions? We have like 3-4 minutes because I have a sharp stop at 7 for today. I think we had one question. Wait, I'll try to find it. If you have questions, you can just ask, or else okay, one person had asked about cap theorem. So okay, so we will cover the cap theorem anyway. I think probably in the next episode. So yes, that can be used in the like real world applications, and we will definitely explain you the factors. Basically, that they are also covered. Cap is also covered in the aspects we are going to discuss anyway. But I will definitely add a slide specific to cap on the next one, because to explain that we need some time.
All right then.
Yeah.
So if there aren't any more questions, we can now finish off the session. So first and foremost, I would like to extend my heartfelt gratitude towards Kasun Delgolla. So for dedicating his time and considerable efforts in enlightening us in these multifactored aspects of enterprise architecture. So as Kasun highlighted, this is merely a beginning of a series of episodes, and we anticipate numerous more enlightening sessions to follow up in the future. So we strongly encourage you all to stay connected across all our various social media platforms, and also to receive like real-time updates on the future events. So yeah, we appreciate everyone's participation in this session, and we look forward to your continued interest in our upcoming activities. So until we meet again in the next episode, thank you all and take care. Good night.
Thanks, Sandur, for organizing this. Thanks, everyone.